Hello everyone, welcome to Payment Tech Media. In this video, we are going to talk about IP version 4 Class A default subnet mask. Let's say they give us IP address of 10.10.0.18, for example. And we already know this is Class A, 10, the first octet, falls into Class A range. And the Class A default subnet mask is 255.0.0.0. Or in other words, we have the Saturn notation of 8. This means 8 bits turned on. In the first octet here, we have 255, right? So let's go over the number of network bits. We have 1, 2, 3, 4, 5, 6, 7, 8, right? 255, 8 bits, and then the rest of the octet all 0. So it's off. Let's write down all the host bits. Alright, so now where is our cut line, where is our network increment? So this is just again one class A IP address with the class A default subnet mask, and we already know for class A default subnet mask is the first octet is network, the rest of them is host. So we just need to write down the cut line between the network. 1s represents network, 0s represents host. So let's just write down this is basically to the left network and to the right our host bits. So we have 8 bits for the network and 24 bits for the host. So we already talked about the number of the formula that we already talked about earlier. So the number of hosts, it's pretty much equals 2 to the power of host bits minus 2, which here we have 2, how many host bits we have? 24, right? 24 minus 2, and why minus 2? Because of the network address and the broadcast address, which you will see we talked about earlier, and you will see later on. So 2 to the power of 24 minus 2 is 16,777,214 IP addresses. So therefore, in every class A network, we can have up to 16,777,214 available IP addresses, because we talked about to find out the number of hosts. For if this is class A, B, or C, it's just simply 2 to the power of host bits minus 2. So for class A, we have 24 zeros, so 24 host bits. And you guys saw earlier in the previous videos that in class B, we had 16 zeros, right? 16 host bits. And in class C, only 8 zeros, 8 host bits. So we had different values. And all right, so well, here we can just write down our basically network address. So the network address would be here 255. This is 10, so just simply writing 10.0.0.0, and then the increment here we can see on the last bit that is turned on. This is the last bit turned on. And this is our network increment. So on the first octet, so if this is 10, next network would be 11.0.0.0. Next network would be 12.0.0.0. Remember, this is just a default subnet mask for class A, which is 255.0.0.0. And when we have the cut line, the last bit turned on, the decimal value is the network increment to find out the next network. Okay, so these are the network addresses. Here we can see in this column. And then to find out the broadcast, always it's better to find the next network, right? And then one less would be the broadcast address. So the broadcast address for this network would be 10.255.255.255. If we just add one IP address to this, it will be 10.255.255.256. We don't have 256, so it will be 0, and add to this one 10 255.256.0, and again we don't have 256 here, so it will be 0 adding to this one 10.256.0.0, and here we don't have 256, it will be 0 and adding to this one, so it will be 11.0.0.0, and here we can see 11.0.0.0. Alright, let's write down the available IP addresses. So the first available IP address is 10.0.0.1, and it goes to the range of this 10.255.255.254. Always one less than the broadcast. Okay, so to find the broadcast address is one less than the next network. How can we find the next network? Using the increments. How did we get the increment? Using the subnet mask. How did we get the subnet mask? Using the IP address, what class it is. This IP address, looking at the first octet, this is 10, is class A. So we know the default subnet mask is 255.0.0.0 for class A. Therefore, this is 255, 8 bits turned on, right? It gives us 255. And then the rest of the bits turned off, which this is our cut line. The last bit turned on, decimal value, increment on the first octet. So incrementing by 1 on the first octet, we can find the next network. So 10, next network would be 11, next network 12, and so on. So the IP address they gave us is a 10 network. Therefore, looking at the 10 network, finding the next network, broadcast one less than next network. So 11.0.0.0, one less would be this, 10.255.255, and then when we have the network address and the broadcast address, then we can have the range. And the range in between, the first available IP address for this network is 10.0.0.1, and it goes to 10.255.255.254, one less than the broadcast. And this IP address 10.10.0.18 falls into this range. So this was an example of using class A IP address with class A default subnet mask, which in this network we have a total of 16,777,214 available IP addresses in this one network. In the next video, we will talk about the quick summary of these classes and how many available IP addresses we can have per class using their default subnet mask. So thanks for watching and have a good day.